Hi guys, welcome to another video. So topic for today is absolute values and modulus. So this is your entry into algebra. It's one of the difficult topics that students find. But in this topic, today I'm going to teach you two simple methods that will help you solve all the questions from this topic. Okay, so we are going to learn two simple methods that will help you solve all the questions from this topic. Okay, and not only are we going to learn the two methods, we are also going to learn when to apply each method. See, one common thing with all the with all of us is we learn different methods for solving a question, but then we forget or we get confused what method to apply when. So not only we are going to learn today the two methods, but we will also learn when to apply which method. Okay, I hope that makes sense. Okay, so having said that, let's start with our topic. So all of you know, right, absolute means or modulus is this sign, which essentially means, right, the answer for plus 5 or modulus 5 is plus 5. Even if I put minus 5, then also the answer is plus 5. Okay, that is the input, which is your value inside the modulus. The input can be positive or negative, but the output is always positive. Okay, the input can be positive or negative, but the output is always positive. Okay, so if I just write this down in theoretical way, what does that tell you? Modulus of x is equal to plus x. Okay, when x is greater than equal to 0. So if x is positive, the answer is plus x. Okay, similarly, modulus of x is minus of x when x is negative. Okay, modulus of x is minus of x when x is negative. Okay, what do I mean by this? So let's look at the previous example only. See, modulus of plus 5 is plus of plus 5. Okay, x is plus 5 here because x is positive, 5 is positive. So plus of plus 5. Plus into plus is plus only. So answer becomes plus 5. Similarly, modulus of minus 5 is minus of minus 5. Okay, because x is negative, minus of minus 5. Negative into negative is again positive, and the answer becomes plus 5. Okay, so modulus, what do we understand? Modulus of x, okay, is plus x when x is positive. Modulus of x is minus x when x is negative. Okay, if you understand this, then using this we learn our first method. Okay, we learn our first method of solving all the questions. Okay, that is modulus of x. Okay, whenever you see any question and you see modulus of x, you break it into two parts. Okay, modulus of x, you break it into two parts. Okay, one with a plus sign. Okay, the other with a minus sign. Okay, one with a plus sign, the other with a minus sign. Okay, but whenever you break this, remember, always write the condition. Okay, remember, whenever you break this, do not forget to write the condition, because whatever answer we get, right, so we will solve the question, we will get some answer here. Whatever answer we get, that answer needs to be verified. That answer needs to satisfy the condition. Okay, if the answer satisfies the condition, okay, then only we say the answer is accepted. If the answer does not satisfy the condition, we say the answer is rejected. Okay, let's look at an example to understand this better. Say we have the question modulus x plus 2 is equal to 7. Okay, so you see modulus x plus 2 equal to 7. What do? We break it into two parts. Okay, we break it into two parts. Now how do we break it? So write down the condition. When x plus 2 is positive or when x plus 2 is negative. Okay, when x plus 2 is positive or x plus 2 is negative. Okay, if it is positive, modulus opens with a positive sign. If it is negative, modulus opens with a negative sign. Okay, we solve this, we get x equal to plus 5. We solve this, we get x equal to minus 9. Okay, now remember, don't rush, verify. Right, so if you see, yes, plus 5 satisfies the condition. Okay, plus 5 satisfies the condition. So this is acceptable. x equal to minus 9, this also satisfies the condition, so that is also acceptable. Okay, so since both the answers are okay, both values are my answers. Okay, so remember, super important point, break the modulus into two parts. Okay, break it into two parts, one with a plus sign, one with a minus sign. Now what is plus, what is minus? The entire modulus. Okay, the entire modulus becomes plus or the entire modulus becomes minus. Okay, don't just write x as plus minus. This entire modulus is replaced with a plus sign and entire modulus is replaced with a minus sign. Okay, the entire modulus, if you see, was replaced with a plus sign and the entire modulus here was replaced with a minus sign. Okay, one more important point, write down the condition. Okay, you might see that, okay, this is not required, why am I writing so much? Okay, but you'll see the importance of it in few minutes. Okay, write down the condition. If your answer satisfies the condition, that answer is accepted. If the answer does not satisfy the condition, okay, the answer is rejected. Okay, so I'll just write two important points here. Okay, write the condition, this is super important. Okay, replace entire modulus with plus or minus sign. Okay, you replace the entire modulus with a plus or minus sign. Now those who don't do this, okay, those of you who don't want to write these condition, okay, those of you feel no, this is too much, I don't want to do that, then do one thing, always verify your answer. Okay, if you don't want to write the condition, no problem, solve it quickly, but then verify your answer. Okay, how do we verify the answer? Just plug this value back in the question. Okay, just plug this value back in the question. So here if I want to verify, okay, here for this question if I want to verify, what will I do? I will put this plus 5 back in the question. Okay, so if I put the plus 5 back in the question, I get 5 plus 2 modulus equal to 7, which is correct because modulus 7 is equal to 7. Similarly, if I put this minus 9 plus 2 is equal to 7. Modulus of minus 9 plus 2 is modulus of minus 7, which is again correct. Okay, so you do one of the two things, either write the condition. Okay, if you don't want to write the condition, plug the value back in your question and verify your answer. Okay, so I hope you understand method number 1. What do? We break the modulus into two parts, replace the entire modulus with a plus sign, minus sign, solve the question. If you have written the condition, then just see whether your answer is matching the condition or not, satisfying the condition or not. If not, if you have not written the condition, then simply plug the value back in the original question and verify your answer. Okay, if you understand this, then I would request you to try this question. Okay, again what do? Break it into two parts. Before we break it into two parts, we write down the condition. When x plus 5 is greater than equal to 0, when x plus 5 is less than equal to 0. Okay, again break this into positive sign, so the entire modulus becomes positive. Replace the entire modulus with negative sign. Okay, we solve this, we get x equal to 6. We solve this, we get, so minus x minus 5 is equal to 2x minus 1. We get 3x equal to minus 4, x equal to minus 4 by 3. Okay, now those of you who did not write this condition and who just got this and think this is the answer, see, this is where you fall into the trap. Okay, just check whether the answers are satisfying the condition or not. Okay, if you see, if I put x equal to 6, 6 plus 5 greater than 0, yes, this is okay. Okay, if I put minus 4 by 3 here, okay, minus 4 by 3 plus 5, is it less than equal to 0? No. Okay, this is not less than equal to 0. So this value is not satisfying the condition. Okay, so this is not my answer. Okay, That is why, guys, see, that is why writing the condition is important. Okay, again, I hope you understand the importance of writing the condition. Okay, see, this is your trap. This is what they call, oh, this is trap answer and not. There is no trap. You are not following the process properly. Okay, you are being lazy. We are just breaking it into two parts, not thinking about the condition and just getting two answers. Okay, if you simply write down the condition, okay, you won't make this mistake. You will know that, okay, this is a false answer, this is wrong, there is only one answer here. Okay, again, if you're not writing the condition, then I will say plug the values back in to verify the answer. Okay, those of you, right, who are not writing the condition, no problem, you got two values, plug it back in the original question. Okay, plug it back in the original question and see, okay, whether LHS is RHS or not, right? So 6 plus 5 is equal to 2 into 6 minus 1, modulus 11 is equal to 11, yes, right? This option verifies. Okay, let me plug this value also, minus 4 by 3 plus 5, okay, minus 4 by 3 plus 5 is 2 into minus 4 by 3 minus 1. If I take LCM here, that's 11 by 3 is equal to, take LCM here, that's minus 11 by 3. Now modulus gives positive answer, so plus 11 by 3, right? And right hand side I have minus 11 by 3, and clearly they are not equal. Okay, clearly they are not equal, so this cannot be my answer. Okay, so again I am repeating myself. Remember, the method is you break the modulus into two parts, no problem with that. Okay, either you write the condition, or once you get the answer, plug it back in to verify your answer. Okay, I hope you understand this. Think of the takeaway, okay, from this method. So your method number 1 was break it into two parts. Okay, so what are the important takeaways that we can learn from this? Okay, right, modulus x is plus x, okay, when x is greater than equal to 0. Second, modulus x is minus x when x is less than equal to 0, right? This we already know. Write the condition or verify the answer. Okay, another important point, if I already know that modulus x is x, if I already know that modulus x is equal to x, then I can say x is greater than equal to 0. Okay, if I already know that modulus x is equal to x, then I can say x is greater than equal to 0, right? Because for positive numbers, whether you write modulus or you don't write, the answer is same. Whereas if modulus x is greater than x, okay, this is only possible when x is negative. Okay, why? Because for negative numbers, modulus will make the answer positive. So the modulus answer will be a positive value, whereas the original number was negative. So for negative number, modulus converts them to positive. So modulus of x is greater than x. Okay. Finally, modulus of x is always greater than equal to 0. Okay, that is, the minimum value of modulus is 0, right? We already know this, that modulus always makes everything positive. Okay, so the least possible value will be 0, or all the other values will be positive. Okay, so I hope you understand method number 1. Method number 1 is to break the modulus into two parts and then simply solve the question. Okay, now another important point, okay, that comes here. Okay, another important point that comes here is, when do I use method number 1? Okay, as I told you that I'll teach you both the methods, and at the same time I'll tell you when to use those methods. Okay, so remember, use method number 1 when you have a single modulus in the question. Okay, when you have a single modulus sign in the question, you can easily break it into two parts, solve it like normal algebraic equation. Okay, or you have multiple modulus Okay, you have multiple modulus on the same side of the equation. Okay, we'll look at this little later on. Okay, there are only two cases when you should use this method. I mean, you can use this method every time, but these are the two cases when it will work much faster. Okay, I'll explain this right little later. You use modulus, this method of breaking it into two parts. If you have a single modulus in the question, okay, then it doesn't matter what side of the equation it is on, quickly break it into two parts and solve. Or you have multiple moduluses but on the same side of the equation. Okay, we'll look at this little later. Okay, so I hope you understand method number 1 completely. So coming on to say a different question. Right now, if you see, we have modulus on both sides. Now, if you remember, I told you in the previous slide that if you have multiple moduluses on the same side of equation, okay, if you have multiple moduluses on the same side of equation, then you use plus minus. Here, if you see, you have multiple moduluses, but they are on either side of the equation. Okay, so why can't we use method number 1? We can use, but the problem with that is, see, you will break this into two signs, plus and minus. You will break this also into two signs, plus and minus. So in all, you will have 4 cases, right? If I have 2 plus minus, how many cases are found? 4 cases are found. So that will be lengthy. Okay, that will be lengthy. That is why if you have modulus on either side, okay, if you have modulus on either side of the equation, try avoiding using method number 1. Okay, then you try avoiding, okay, using method number 1. Okay, so question comes then, okay, if I avoid method number 1, then what do I do? Okay, so then let's look at our method number 2. Okay, this again comes from logic, right? See, let's take a step back and think again. Okay, what does absolute do? Okay, what does absolute do? For plus 5 and for minus 5, it gives us the same answer, right? For plus 5 and for minus 5, it gives us the same answer. Okay, now think, do you know any other operation in math? Okay, do you know any other operation in math that gives you the same answer for both plus and minus 5? Okay, think about it. Do you know any other operation that the answer of which, if I put plus 5 also or minus 5 also, I get the same answer? Right? Think about it. Yes, right? If you think, if you have said square or if you have thought about squaring, yes, right? If I square both sides, right? If I just do plus 5 square and if I do minus 5 square, right? Both of them give me 25. Okay, so point being that if you square, right, you get the same answer. So this is where our method number 2 comes from. Okay, that is, if you want to remove modulus, okay, you can simply square both sides. Okay, if you want to remove modulus, okay, you can simply square both sides. Okay, square both sides. Okay, I'm trying to learn how the board works, so pardon me for that. Okay, so the method number 2 comes from a simple logic that, see, modulus gives you the same answer for plus or minus values. Okay, another operation in math that does the same is squaring. So to remove the modulus, you can simply square both sides. Okay, let's see how that works. So if you see this question, we have modulus x plus 5 is equal to modulus 2x minus 1. Okay, if I square both sides, what happens? This whole thing square, this whole thing square. The modulus and square goes. Okay, you get x plus 5 the whole square is equal to 2x minus 1 the whole square. Okay, now do not rush and do a plus b whole square and solve quickly. Okay, don't do that. Wait, get this on the other side. Okay, don't just rush and square and make a quadratic. Hang on, right? Right, hold your horses, right? Get it on the same side. Now apply a square minus b square. Okay, now apply a square minus b square. So you have 2x minus 1 plus x plus 5, 2x minus 1 minus x minus 5. Okay, you will get 3x plus 4 and x minus 6. Right, now if you know the quadratic equation, you know from this the answer is x equal to 6, x equal to minus 4 by 3. Okay, the answer is x equal to 6 and x equal to minus 4 by 3. Again, because this is a trick, what will we do? We will again verify our answer. Okay, again what will we do? We will verify the answer. Okay, now if you see, because you have modulus on both sides, both the values will satisfy. Okay, since we have modulus on both sides, if you plug it back in and verify, both the values will get verified. So both the values are my answer. Okay, so method number 2, what is it? If you want to remove modulus, simply square both sides. Okay, so again let's focus on the takeaway of this method. Okay, point number 1, when do we use the method? When you have modulus on either side of the equation. Okay, when do we use this method? When you have modulus on either side of the equation. Okay, because what is the advantage? When you square both sides, in one shot both the modulus will go away. Okay, both the absolute values will go away, and then you'll end up with a quadratic equation. Okay, and remember, don't just like try to solve quadratic, try to get everything on the same side. Use a square minus b square. That will help you solve the question much more quickly. Okay, now super important takeaway. Okay, super important takeaway. Square root of variables. Okay, square root of variables is always modulus. Okay, what does this mean? Okay, that if x square, okay, if you take a square root of it, don't write this as x. Okay, this is modulus x. Okay, square root of variables is always modulus. Okay, so square root of x square is modulus x, and then you solve this modulus x as plus minus x. Okay, then you replace this modulus x with a plus minus x. Okay, whereas square root of numbers is always positive. Okay, square root of numbers okay, what does this mean? Square root of 9 is plus 3. Okay, square root of 9 is plus 3. Okay, so if you get a question, x square is 9, what actually happens is, when you do square root, right, when you do square root, this becomes modulus x is 3, modulus x is actually plus minus x, and then the plus minus goes there and becomes plus minus 3. Okay, what we usually do is, we directly go from this step to this step. So we think that okay, square root of 9 is plus minus 3. That's not the case. And similarly, square root of x square is x. That's not the case. The point is, square root of x square is modulus. The modulus then is plus minus, and hence x is plus minus 3. Okay, so remember, this is super important. Square root of variables is always modulus. Okay, alright, I hope you understand this. A quick recap. Method number 1, break the modulus into two parts, plus and minus. When do we use it? When you have single modulus or multiple modulus on the same side of the equation. Method number 2, to remove the modulus, square both sides. When do we use that? When you have modulus on either side of the equation. Irrespective of the method you use, irrespective of the method you use, verify your answer. Okay, I hope you understand this. Let's move to questions. Alright, so I hope you have read the question. Okay, now see, we have single modulus. Okay, so if we have single modulus, what do? We break it into two parts. We will use method number 1. Okay, we'll break it into two parts, right? So mod x minus 8 is 2x minus 4. Break it into two parts. Either you write the condition or you plug the value back in to verify your answer. Okay, remember that when the value inside the modulus is positive or when the value inside the modulus is negative. Okay, so if I solve this, modulus will be replaced with a positive sign, okay, or the entire modulus will be replaced with a negative sign. Okay, if I solve this, I will get x equal to minus 4. Okay, x goes there, minus 4 comes here, right? If I solve this, okay, 12 is equal to 3x, x equals to 4. Okay, so I get two values, x equal to minus 4, x equal to 4. Okay, again, do not rush and say, okay, minus 4, 4, these are my answers. See, right, does it even satisfy the condition or not? Okay, minus 4, if I put here minus 4 minus 8 greater than equal to 0, not happening. This is rejected. Okay, this value is rejected because minus 4 does not satisfy the condition. Okay, x equal to 4, if I put 4 minus 8 less than 0, yes, this satisfies the condition. So this is accepted. Okay, this is accepted. So now if you read the question, sum of all values, okay, do not rush and say the answer is 0 because minus 4 plus 4 is 0. Okay, minus 4 is a false answer, it's rejected. Okay, the correct answer is plus 4. Okay, the correct answer is plus 4. Those of you who don't want to write the condition, just plug it back in the original question and verify. Okay, if you don't want to write this condition, plug the values. Okay, if I plug it back in, minus 4 minus 8 is equal to 2 into minus 4 minus 4. Okay, modulus of minus 12 is equal to minus 12 plus 12 minus 12. Plus and minus are not equal, so that is why this is rejected. If I put this value in, that's 4 minus 8 is equal to 2 into 4 minus 4. Modulus of minus 4 is equal to 4. Yes, modulus of minus 4 is 4. This value is verified. So x equal to 4 is verified. Okay, again I am telling you guys, I am repeating again and again. See, this is the difference between somebody getting a 99 percentile versus getting a 90 or little less. Okay, always when you are doing modulus, verify your answer. Okay, I hope you understand this now. I hope you have read the next question. So if you see, right, we have modulus on either side of the equation. Okay, so don't, like, you can solve using method 1, but there will be 4 cases. Instead, opt for method number 2. Okay, opt for method number 2, which is square both sides. Okay, you simply square both sides. Okay, what happens? Modulus x minus 5 whole square is modulus x whole square. Square modulus goes away. This becomes x square minus 10x plus 25 is equal to x square. X square cancels. 25 is equal to 10x. X is equal to 2.5. Again, do not rush. Okay, again, do not rush. Verify the answer. Okay, plug it back in the original. Okay, to verify the answer. Okay, so if I try to verify, right, modulus 2.5 minus 5 should be equal to modulus 2.5. Right, this is modulus of minus 2.5 equal to modulus of 2.5. Yes, right, this is verified. Right, both the values are equal. This is verified. Hence, the value of x is 2.5. Okay, because we had modulus on either side of the equation, method number 2 was faster. Now this question is exactly same as the previous one, but what they're asking is different, right? Now we want sum of the roots. Okay, but again if you see, we have modulus on either side of the equation. So what do? We opt for method number 2. Okay, we simply opt for method number 2, that is to square both sides. Okay, again square both sides. Okay, square both sides, we get x minus 2 whole square is 3x plus 1 the whole square. Okay, that is x minus 2 whole square is equal to 9 times, right, x plus 1 the whole square. Okay, now again there are two things you can do. As I told you, you can square, like you can open a plus b whole square, or a smarter thing is get everything on the same side. Okay, get everything on the same side. So that is 9x plus 1 whole square minus x minus 2 the whole square. You can apply a square minus b square. So that is 3 into x plus 1 plus x minus 2 and 3 into x plus 1 minus x minus 2 equals to 0. Okay, a plus b into a minus b. Okay, if I simplify this, that is 4x plus 1 and this is 2x plus 5, right? If you solve this, right, if you solve this, you get x equal to minus 1 by 4 or x equal to minus 5 by 2. Okay, again verify the answer. Okay, plug it back in to verify. You will see that both the values are verified. Okay, you will see that both the values are verified. Okay, so then what are they asking? Sum of roots. So minus 1 by 4 plus minus 5 by 2. Okay, if you solve it, that's minus 11 by 4. Okay, what are they asking? Sum of the roots. So add the two, minus 11 by 4. Okay, guys, there is one more interesting thing. Okay guys, there is one more interesting thing that we could have done here. People who are, squaring, so this is where we said, right, that okay, get everything on same side to solve. Those of you who open this with, like, a plus b whole square and a minus b whole square, okay, you will get x square minus 4x plus 4, okay, is equal to 9x square plus 18x plus 9. Okay, 9 gets multiplied to this, you get everything on same side, you will get 8x square plus 22x plus 5 equal to 0. Okay, now what is sum of roots formula? Okay, this is a quadratic equation, don't solve it. What is sum of roots formula? Sum of roots is minus b by a, right? So if you do that, that's minus 22 by 8, which is minus 11 by 4. Okay, so if you're squaring, no need to find the roots, just apply sum of roots formula, that's minus 22 by 8, which is minus 11 by 4. Okay, alright, so if you read this question, again you will see that we have a single modulus. Okay, so obviously we'll go for method number 1, but again don't rush, hold your horses. Okay, if you just observe, okay, we have 3 minus x as mod x minus 3. Okay, if you just take minus sign common, okay, if you simply take minus sign common, you will realize minus x minus 3 is equal to mod x minus 3. If you see, the values are same. Okay, now when does this happen? So if you look at the takeaway that we did for method number 1, okay, it was you break the modulus into positive sign if the value inside the modulus is positive, and you break it into negative sign when the value inside the modulus is negative. Correct? That is, right, modulus of x is equal to minus x. When does this happen? When x is negative. Right? When does this happen? When x is negative. Right? So what do we understand from this? Okay, if we apply the same thing here, right, modulus of x minus 3 is equal to minus of x minus 3. Okay, when will this happen? When x minus 3 is negative. So x is less than equal to 3. Okay, if you simplify that, x is less than equal to 3. Okay, so remember, okay, again, try not to plug in. Okay, I know a lot of people for absolute or algebra in general, if we don't understand, we try to plug in, but let's take time. Okay, we have time for our exam, might as well understand the method. Okay, remember, this is your takeaway from method number 1. Modulus x becomes minus x when x is negative, right? So the same thing we applied here. Okay, and we got x is less than equal to 3. Alright, again, if you see, we have, okay, multiple moduluses but on the same side of equation. So what method we should use? Yes, method number 1, correct? If you have multiple moduluses but on the same side of equation, we use method number 1. Okay, so the question goes, okay, what do we do? Method number 1 says break the modulus into 2 parts. Okay, so let's break it into 2 parts. Okay, so the entire modulus will be replaced with a plus sign. Okay, the entire modulus, outside modulus is replaced with a plus sign. Okay, and likewise the entire modulus is replaced with a negative sign. Okay, the entire modulus is replaced with a plus sign and entire modulus is replaced with a negative sign. Again, you have to write down the condition. Okay, or else you can simply verify the answer in the end. Okay, the condition here will be, okay, the condition here will be the entire modulus, right? Modulus of x plus 2 minus 3 greater than equal to 2. Okay, sorry, greater than equal to 0, or modulus of x plus 2 minus 3 less than equal to 0. Okay, so you break it into the 2 conditions. Okay, if I simplify this, okay, I get modulus x plus 2 is equal to 5, or if I simplify this, modulus x plus 2 is equal to 1. Okay, if I solve this, I get 2 conditions. Okay, modulus x plus 2 is equal to 5 or modulus x plus 2 is equal to 1. Again, if you see, we have modulus. Again, method number 1, break this also into 2 parts. Okay, break this also into 2 parts. Okay, first with a plus sign and then again with a minus sign. Okay, again this with a plus sign or with a minus sign. Again, do not forget, write down the condition. When x plus 2 is positive, x plus 2 is negative. Again, x plus 2 is positive, x plus 2 is negative. Okay, now that you have 4 cases, now we solve. Okay, solve this, you get x equal to 3. Okay, solve this, you get x equal to minus 7, x equal to minus 1, x equal to minus 3. Okay, now since you have written the conditions, you can just plug it back in the conditions to see whether they are verified or not. Okay, if you see, this is verified. Okay, if you see this, this is also verified. If you see this, this is also verified, and so all 4 values are verified. Okay, you just check with respect to each individual condition, all the values are verified. Okay, interestingly, you see all the values are given here. Read the question again. We want range of the roots. Okay, we do not want the roots, we want range of the roots. Okay, range in math is highest value minus lowest value. Okay, range means highest value minus lowest value. If you see, that is plus 3 minus minus 7. So 10 is your answer. Okay, 10 is your answer. So again, remember, multiple modulus on same side of the equation, use method number 1, it will be easier. Again, if you see, this is modulus with an inequality, but that does not change our approach. Single modulus, we use the plus minus method. So modulus p plus 2 is less than 7 by 2. Break it into two parts. Okay, write down the condition when p plus 2 is positive and when p plus 2 is negative. Right? P plus 2 greater than, I'm just writing it decimal, 3.5, and minus of p plus 2, okay, I'll just put a plus sign here, right, is less than, okay, 3.5. Okay, I think I made one mistake. Let me just rectify it. Okay, the question has negative sign. Okay, the question has negative sign. Okay, so again, if I solve this, p is less than 1.5. Okay, if I solve this, minus p minus 2 is less than 3.5. P goes there, 3.5 comes here, 5.5. Okay, now remember, this answer is valid only for this condition. Okay, and this answer is valid only for this condition. So from here I know P is less than 1.5 and greater than equal to minus 2. Okay, this minus 2 is coming from here. If I solve this, P is greater than equal to minus 2. Okay, if I solve this, P is less than equal to minus 2. Okay, so this minus 2 is coming from here. Similarly, the answer for this will be less than equal to minus 2. Okay, however, if I combine, the minus 2 will merge. Final answer will be P is between minus 1.5 and plus 1.5. Okay, P is between minus 1.5 and plus 1.5. Okay, now what are they asking? How many integer values? Okay, so we don't want the range or anything, we want integer values. So integer values, if you see, it's from minus 5 to 1. Okay, integer values are from minus 5 to 1. So if you count them up, that's 7. 5 negative, 1 positive and 1 0. Okay, don't forget the 0. Okay, 5 negative, 1 positive and 1 0. So these are 7 values. Alright, so if you read this question, you will see there are multiple modulus sign. Okay, again you might think, oh, so many modulus, what do we do? Remember, modulus on either side of the equation, we use method number 2. Method number 2 is to square both sides. Okay, so let's see how that goes. Less than modulus x plus modulus y. Okay, what do I do? I simply square both sides. Okay, so I will get modulus x plus y the whole square less than mod x plus mod y the whole square. What will happen? The square will come inside, take away the mod, this will become x square plus y square plus 2xy. Okay, here the modulus can't come inside because we have two separate terms, so we will apply a plus b whole square. So that is mod x whole square plus mod y whole square plus 2 mod x into mod y. Okay, remember there is a difference between the two. This is one whole term, whereas these are two separate terms. Okay, simplify that. X square plus y square plus 2xy less than mod x square is x square, mod y square is y square, okay, plus 2 mod of xy. Okay, now if you see x square cancels out, y square cancels out, you get 2xy is less than 2 mod xy. Okay, 2xy is less than mod 2xy. 2 and 2 cancels out, xy less than mod xy. Now, a couple of questions ago, we discussed this. Okay, when is mod x greater than x? Okay, this is on a takeaway also, that if mod x is greater than x, we know x is negative, right? We know x is negative because for negative number, modulus will become positive, negative number will remain negative, so mod x will be greater than x, right? So applying that here, we get to know that xy has to be negative, right? So when does the inequality hold? When xy is negative. Okay, on to the next question. Okay, we have square root of 16 plus x square minus 8x. Again, do not plug in values. Okay, try to solve this theoretically. Okay, we know we have done this in method 2. Square root of variables is modulus, right? Let me simplify this. Okay, don't, like, you can plug in values, but avoid that. Okay, try to solve it theoretically, right? This is 4 square plus x square minus 2 into 4 into x. Okay, so if you see, this is a square plus b square minus 2ab, right? So you can write it as x minus 4 the whole square. Okay, you can write it as x minus 4 the whole square. Okay, now we did the takeaway for method 2. Square root of variables is modulus. So don't just cancel this and write x minus 4. Okay, and then this option. This is wrong. Okay, we can't do this. Okay, square root of variables is modulus. Remember that. So this will become modulus of x minus 4. Okay, this will become modulus of x minus 4. Okay, now if you see, we don't have x minus 4, but we do have 4 minus x. Okay, now see, for modulus or squares, they are the same thing. Okay, see, you write a minus b whole square or you write b minus a whole square. They are the same thing. Okay, they are the same thing. So what does that mean? Instead of writing this as x minus 4 whole square, you can also write this as 4 minus x whole square. Okay, instead of writing from here to here as x minus 4 whole square, you can take 4 as x and 4 as a and x as b. So this will become 4 minus x whole square. Square root will become modulus of 4 minus x. Okay, square root will become modulus of 4 minus x. Okay, so remember, square root of variable is modulus. Okay, do not rush an answer. Square root of variable is modulus. Okay, moving on to the next one. Okay, we see that sum of two modulus is 0, right? We have mod 4x minus 3y plus 6 plus mod minus 5x plus 2y minus 4 is equal to 0. Again, do not rush and break it into plus minus. Think for a minute. Okay, think logically. See, what do we know? Okay, we know that modulus is always greater than equal to 0, right? In short, the answer of modulus is always positive or 0. How can sum of two numbers be 0 when none of them can be negative? Okay, how can the sum of the numbers be 0? Okay, the only way this is possible is individually. Okay, individually they have to be 0, right? Because 0 plus 0 will give you 0. Okay, because either they are 0 or positive. Okay, so when you add them up, the only way answer can be 0 is 0 plus 0 is 0. That means 4x minus 3y plus 6 is 0, and likewise minus 5x plus 2y minus 4 is 0. Okay, again you can square both sides, or you can simply say that okay, the only way it is 0 is the value itself is 0. So we get simultaneous equation 4x minus 3y plus 6 is equal to 0, minus 5x plus 2y minus 4 is equal to 0. Okay, so we get two equations, simultaneous equation. Okay, if you want, okay, let's eliminate y. So I multiply this equation by 2, multiply this equation by 3, and add them, right, and add them. Okay, I get 8x minus 15x minus 6y plus 6y plus 12 minus 12 equal to 0. Okay, 6y cancels out. Okay, 6y cancels out, 12 cancels out. Okay, what do I end up with? Minus 7x is 0, which means x is 0. Okay, so I get x as 0. Now what do? I can substitute x in any one of these equations. Okay, so say I substitute in the first one, 4 into 0 minus 3y plus 6 is 0. Okay, I get minus 3y plus 6 is 0, y is equal to 2. So I get x as 0, y as 2. Okay, now what are they asking? 3x minus y. So that is 3 into 0 minus 2, which is minus 2. Okay, which is minus 2. Now if you see, these are simultaneous equations. Okay, we have two equations here. We have 3x plus y is equal to 15. Okay, and we know modulus of y is less than equal to 10. Okay, again single modulus, what do? We break this into two parts. Plus y is less than equal to 10, minus y is less than equal to 10. Okay, so we get y is less than 10, y is greater than equal to minus 10. Okay, so when we break it into two parts, we get two conditions, y is less than equal to 10 and y is greater than equal to minus 10. Okay, from the first equation, the value of y is 15 minus 3x. From the first equation, value of y is 15 minus 3x. Right, now think of it like simultaneous equation. You know y from equation number 1, you know y from equation number 2. What you do? Substitution method. Okay, we can simply substitute it. So this value goes here. Okay, this value goes here. We have 15 minus 3x less than equal to 10. We get 5 less than equal to 3x, x greater than equal to 5 by 3. Okay, similarly this value will now go here. Okay, we get 15 minus 3x greater than equal to minus 10, 25 greater than equal to 3x, x less than equal to 25 by 3. Okay, if we combine the two, we get x is greater than 5 by 3 and less than 25 by 3. Okay, x is greater than equal to 5 by 3 and less than equal to 25 by 3. Okay, now again let's read the question. We want integer pairs. So we want the values of x to be integers. So if you look here, the integer values are going to be x is greater than equal to 2 because 5 by 3 is 1.6. So x can be 2, less than 8.33. So 8.3 means x can be 8. So essentially x can be between 2 to 8. And for each value of x, we will get an integer value of y. Okay. Now remember, it doesn't say positive, it just says integer. So y can be negative also. Okay. Y can be negative also. So if you see, we have 7 different values of x. Okay. From 2 to 8, we have 7 different values of x. That is why we will get 7 different corresponding values of y, and hence 7 integer pairs. And hence 7 integer pairs. Okay. Alright guys, I hope you were able to understand absolute values, you were able to understand the concept. Not only that, the 2 different methods to solve all the questions and when to use which method. Okay, remember, whenever you are doing multiple methods, it is equally important to know when to use which method. Okay, my request to you would be that please practice this. Try and avoid using plugging in values. I know in algebra you can do that, but try to understand this. See, you have a lot of time. Okay, you have a lot of time to practice right now. If you understand the concepts and solve questions conceptually, your confidence will increase. So while you are answering the questions, you will answer the questions confidently. Okay, whereas if you are plugging in values, you won't be sure that, okay, is this the right answer or not? Okay, or have I plugged all the possible values or not? Okay, whereas if you solve it conceptually, you will be confident while you are answering the questions. Okay. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and try to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.